If you could pick one thing that you use every day that you couldn't live without, what would it be? Would it be your phone, your sweater, or maybe your dog for, well, obvious reasons? Well, what if I told you that none of these things would be possible without Earth's number one most critical resource, water? Water is used in almost every process you can imagine, from the food and drinks we consume to all the technologies we use daily.
But if that is the case, why do we constantly hear about water shortages across the world? Are we running out of water, or are we failing to manage the water we already have? Water has shaped human civilization for over 10,000 years, with early communities forming around fresh water. As people moved farther away, they had to develop new ways to manage and transport this essential resource. One such innovation came from the discovery of groundwater. You see, water isn't just stored on the surface of the earth. It can also be found in underground pockets called aquifers. Another innovation that changed water management was the aqueduct. This system transports large amounts of water from mountain springs, rivers, lakes, and reservoirs using gravity, allowing sources at higher elevation to reach lower elevations.
But wait, with all these innovations, didn't we solve water management? In the past, maybe. But today's challenges require new solutions. In the United States, due to challenges brought on by hyper-urbanization along with the rapid westward expansion, the US government created dedicated federal agencies like the US Army Corps of Engineers and the Bureau of Reclamation to design large-scale infrastructure such as dams and reservoirs. These projects relied on advances in hydrology, fluid mechanics, and structural engineering to control floods, store water, and even generate hydropower, showing that water isn't just a resource, but also a source of energy.
What if one project could transform a dangerous, unpredictable river into a reliable source of water and energy for an entire region? That's exactly what the Salt River Project did. In the past, the Salt River frequently flooded the Phoenix area, making development difficult. Starting in 1911, engineers designed a system of dams, reservoirs, and canals to control flooding and store water for long-term use. This required careful analysis of flood patterns, watershed mapping, and early hydrologic modeling, scientific approaches that allow the system to reliably supply water to millions of people and support Arizona growth.
Large-scale projects like these have helped reduce flood risks, but they're no longer enough for today's water challenges. What's changed is the rapid, human-driven acceleration of climate change, which is putting new pressure on water systems. In places like Arizona, water has become more limited as conditions grow hotter and drier, affecting infrastructure like the Central Arizona Project, a massive delivery system used to transport water from the Colorado River to populations in the state, which has seen river flows decline and reservoirs reach historically low levels.
To address this problem, new technologies are being deployed to make Arizona more water efficient. One of these is low-flow household fixtures. Think about how much water you use every day for washing hands, waiting for the shower, and doing small loads of laundry. That is a loss of water going straight into the drain. Arizona identified this problem and introduced water-saving standards for household fixtures. These fixtures are principles like pressure flow relationships and turbulence control. Engineers test nozzle geometry, aeration, and flow restrictors to maintain strong water pressure while reducing volume. These advancements don't just come out of the crowd, however. They are built on foundational research from universities such as the Georgia Institute of Technology and Purdue University, where basic science is translated into real-world water management solutions. Applying this research to Arizona water situation has resulted in residents using 25% less water than the national average.
Another technology being widely adopted is drip irrigation. Water is pumped through a network of pipes and small tubes, releasing precise amounts either at the surface or below the soil. Researchers studied how water spreads through soil and how plant roots absorb moisture, using that data to design systems that target the root zone instead of wasting water on the surface. Engineers then translated these findings into technology, developing emitters, pressure regulators, and tubing layouts that ensure consistent and efficient delivery. Drip irrigation is especially important in Arizona, where agriculture uses about 72% of the total water. By targeting the root zone, it minimizes evaporation and runoff, significantly improving efficiency. However, it's not perfect. These systems can be costly to install, and the small tubes are prone to clogging, requiring regular maintenance and possibly government support.
While these technologies are already improving efficiency today, future innovations are being built to make water management even smarter. For example, researchers at a university in Turkey developed a system that combines infrared cameras and robotics to detect water leaks in drip irrigation systems. In practice, companies like megaprojects are already applying similar ideas using AI and sensor-based automation to adjust irrigation based on soil moisture, weather, and crop conditions.
There is one more piece of the puzzle, however, that goes into water management in Arizona, and that is the ongoing Colorado River negotiations. The Colorado River supplies water to about 40 million people across the western United States. And right now, 7 states, along with Mexico, are arguing about how the water should be allocated, with the federal government threatening to intervene if a deal is not reached soon. How much pressure is exerted on these technologies hinges on how this situation gets resolved. But one possibility is that farmers, along with individual municipalities, might lose a portion of their water rights. The reallocation of water won't just affect agriculture, however, as water systems are deeply interconnected. Dams, for example, not only store water, but also generate hydropower. Lower reservoir levels mean less electricity production, which can impact energy supply across the Southwest. This creates a feedback loop where water and energy systems depend on each other, making the entire network vulnerable to disruption.
So, where do we go from here? The future of water management lies in integrating advanced science with new technologies. This is being done today as researchers are exploring desalination, wastewater recycling, and improved groundwater modeling in order to create smarter infrastructure, gather better data, and propose more adapted policies that will be able to respond to uncertainty.
But to do this properly, we must remember that water is not just a resource. It is the foundation of the interconnected systems that sustain not just our lives, but all life on Earth.